Hey, welcome to week 3 of Art and Code. You made it through the first 2 weeks, and now we're kind of on the downhill slope, so halfway through. This week, we're going to be exploring natural movement, which essentially means we're going to be looking at sine and cosine and also Perlin noise. The last 2 weeks, we talked about recursion and motion. We also talked about art composition in week 2. The week before that, we talked about color and structure, how to structure a sketch, and then also how to make some generative color palettes. This week, we're going to review what we did last week regarding composition. Then we're going to look at Gestalt Psychology, which is sort of another way of looking at how people perceive art, visual art. And then we're going to talk about sine, cosine, and noise. So how to bring those things into your motion to make things feel more natural, and how exactly one might map those to natural motion. So what are these things good for? How would I use them? A lot of this week code-wise is just going to be examples of how to bring sine and cosine into your code. And I'm going to hand you those tools so that you can bring them into your generative art pieces. Just getting sine, cosine, and noise set up is quite a bit of work. So we're going to focus on the conceptual side of utilizing sine and cosine so that you're able to pull that into any kind of work that you're already doing. And then we're obviously going to do our code demo. Before we do anything though, let's hop over to the P5.JS website. I want to show you where the docs are, how to find them, because I think it's super important for you to reference them. And in fact, I put this in the end of lecture 1 and lecture 2 and got so invested in utilizing our code time that I totally forgot to show you how to get to the references. So let's just briefly hop over there. We'll talk through it so that you know what the references are, how to use them, why they're important. Okay, so here we are, we're on the reference page for P5.JS. The reference page is located at p5js.org/reference. And it's super great because you can see there's a search bar here. If you want to get to the reference from the main page, you can utilize that search bar on p5js.org, or you can go ahead and click on that left-hand side that says reference from the homepage and it'll take you to the same place. I'm going to show you how to utilize the references just so that you can understand how you might utilize this in your code. It's a great way to look for something that you're having trouble with, and either it's the end of the course and office hours are unavailable, or you're just looking for a quick fix. So here you can see we've got the ellipse documentation. We've utilized an ellipse before. They show you a quick example at the top of the page, and then they break down each of those parameters, talking about what each of them actually means. This is a great place to go if you're looking to expand your skills. It's also a great place to go if you just have a quick question on how to utilize one of the parameters inside of your code. And I utilize the docs all the time. I think these are top tier docs. So as far as a library goes, these are really fantastic for utilization in your code work, and I strongly recommend you spend some time with them. So again, that's p5js.org/reference, and take a look at them so that you can also use me as a resource for how to navigate around the docs if you have any questions about that in this class. Cool? So let's jump back over into our lecture. I just wanted to give you a quick overview of how the documentation works and where to find it so that you can use that in your own work in the future. Okay, awesome. So here we are, we're back on our lecture, and we're going to start by going into a review of art composition. So last time we talked about how art composition is kind of made up of 2 concepts. The first being the visual elements, which I used a metaphor, an example of like a house is built out of walls and windows. However, a house can be described as spacious or cozy. So the walls and windows would be the visual elements of a house, and the principles of composition of architecture might refer to something like spacious or cozy or warm, something like that. We talked about visual elements of art. So what are the actual pieces that make up an art piece, and how can you look at those things? How can you, tear a piece apart and see what it's actually made out of? We talked about line work and how lines can be thick or thin. They can be scratchy or smooth. They can be long or short, curved or straight. And we talked about the fact that when you're making generative art, you have to be really conscious of the ways that you're drawing your lines. When you're doing art on a piece of paper, a lot of times the way that you create that art, whether it's a marker or you're cutting out with an X-Acto knife or something like that, that kind of affords a certain type of line. P5.JS also affords a certain type of line. Typically, these are smooth lines. And if you're not doing anything to modify them, they're just going to be straight lines with like hard corners on them. So being critical of the lines that you're using, what the line thickness is, whether you have stroke on in your piece at all, super important to the way people are going to perceive that work of art. We talked about how shapes are balanced differently in different works of art. And the best way to get an idea of really any of these visual elements is to start looking at other people's works. We talked about how tone and color are kind of different but very related. So what is the contrast like in your piece? Is it very light, very dark? Is there a lot of dynamic range inside of that tone? Are you seeing things that are very warm, very cool? And then we talked about color in terms of color palettes. So are they using an analogous color palette? Are they using a contrasting color palette? Where on that color wheel are they grabbing colors from? Patterns, of course, are lots of repeating elements, and they can appear in lots of different ways in lots of different places throughout a piece. So utilizing a pattern that is dappled around your piece might create a sense of balance, or using many patterns might create a sense of dissonance. So looking into the way an artist is using repeating elements in a work of art. We talked about texture and the ways that you can utilize texture in your work in P5.JS. A lot of the pieces that I've shown you have some sort of overlaid texture on them, and I did promise you that I'm going to show you how to use texture in your work, so we'll visit that a little bit in our code demo as well today. And then last, we talked about form. So what volume is occupied by your subject versus your background. This is different than shape because shape is just focusing on the overarching shape of each element in the piece, whereas form is actually looking at the entire subject and the way that it's shaped and how it takes up space. Form is definitely going to come back inside of our Gestalt psychology today, so keep an eye out for it. Then we take all of those things and we combine them into this overarching language for discussing art composition. So what is the flow of a piece? What's the rhythm? Do you get hung up on certain parts of it, or does it feel very smooth? Is it balanced and symmetrical, or is there a lack of balance that's creating a sense of emphasis on a certain part of the piece? Or, for example, is the artist utilizing the rule of thirds and placing their subject inside of that third of their canvas to create a really intense emphasis on a single piece? Gradation, so are any of the changes color-wise, shape-wise, form-wise, are they gradual or are they immediate? Are you seeing a lot of contrast or very little contrast? We talked about harmony and variety. So this can be any type of, again, any type of element from the previous slide can be utilized in a harmonious way or can have a lot of variety in it. So are you seeing visual elements repeated often inside of the piece? Or are you seeing lots of contrast? Is that creating a sense of balance and emphasis? So what exactly is happening there? So all of these things are kind of stacked on top of each other to create a rhetoric of artwork. Then we talked about movement. Just a quick reminder that movement is referring to a sense of movement in a work of art. It does not have to deal with actual physical movement inside of a work of art. However, physical movement has its own level of movement, and we are going to talk about that as well in Gestalt psychology. But essentially, does the piece feel still and calm, or does it feel really active? Does it feel like the subject is moving to somewhere else? We showed some examples of a real intense sense of movement in a piece of art. The contrast to that would be the Frida Kahlo piece that we looked at is a very still work of art. The subject is laying flat and there's no sense that anyone is going anywhere. The last way of discussing composition in art is proportion and scale. So do you see things that are very similarly sized, or are they very different? Are you seeing a really regular sense of scale? So are things going towards a vanishing point, or are things irregular and maybe non-realistic? How is the artist utilizing scale to create a sense of feeling or purpose or theme inside of their work of art? So last thing that we're going to visit, which I think is the most important part of art composition, and it does apply to this Gestalt psychology as well. When you have the language for something, you're able to discuss that thing and to see that thing. So there is some research that shows that cultures that don't have names for colors are unable to perceive those colors. So if you don't have a name for movement or balance or emphasis inside of this art frame, you're not going to be able to see that, and therefore you won't be able to apply that inside of your own work. So that's why we're discussing the ways that you look at artwork so that you have the ability to self-reflect and also to look critically at other people's art so you can bring their elements inside of your work. So all I can really do is teach you language, ways of looking. It's your job to go do the looking and find the inspiration. So go find the art that feels right to you, that inspires your own work. Utilize these frames to then bring those concepts into a piece of art that you are trying to create in P5.JS. Today, we are going to focus heavily on the math for art section. And then, of course, the art side, the theory side of our lecture today is going to be entirely Gestalt psychology. So now we're kind of checking off all of these boxes, which is kind of incredible. We've already talked about art composition and color theory. We've dabbled in math for art, utilizing recursion. We also talked about Sine a little bit right at the end of our code demo last week. We're going to look into that in more detail this week. And then, of course, next week, we're going to finish out utilizing data visualization and APIs. Cool. So let's jump into the theory part of this week's lecture, talking about Gestalt psychology. So Gestalt psychology is this form of psychology that began at the beginning of the 20th century that's based around the belief that humans should be looked at as an entire system rather than looking at your mind and body as separate things. So they basically argue that there's a biological basis for the ways that humans perceive the world around them. And they end up in all of this experimentation finding some universal principles for the ways that people perceive things. And specifically, they're really interested in the ways that people perceive grouping. So Gestalt actually means grouping or something to that effect in German. There are a very similar set of principles in Gestalt psychology to art composition. So first there's a way of looking, and then we're going to look at the actual deep down principles. So we're kind of going backwards. We're going to look at the overarching umbrella, and then we're going to zoom in and look at each of the individual principles and how you might apply that inside of your work. Inside of this framework, basically the discussion is around how your brain might actually work to perceive things, and we've narrowed it down to 4 basic principles. The first principle is reification. Basically, the idea is that humans perceive things as more than just ink on a page, so we like to make meaning out of things that maybe are even a little bit abstracted. So when you're looking at even an abstract work of art, people are often asking themselves, what does this mean? How does this look? Is this representational? And that's the real idea behind reification. Humans really like to make meaning out of a piece of art or anything, for example. Multi-stability is the idea that if you are having an ambiguous perceptual experience, your brain will flip-flop back and forth between either of those things. So the dress that went around on the internet, the blue and black and white and wasn't it yellow, something like that, that would be a great example of multi-stability. If you can see both of those options, your brain is going to be flipping back and forth. You can't see both at the same time. That's the concept of multi-stability. Invariance is the idea that your brain can tell that an object is the same regardless of the way that it's oriented or the way that it's lit. So, for example, I've got this flash drive here. If I show it to you at this angle, you'll be able to perceive it at any angle and know that it's the same object. It's kind of a magical thing, in my opinion. People don't get confused when you show them a glass that's upside down. You know, our brains are able to consistently perceive something, even if it's rotated or lit differently. And then the last principle in this framework is emergence. Basically, the idea here is that we make meaning by seeing things as parts of a whole rather than just seeing them as parts. So there's a big relationship between reification and emergence. Again, the idea is that you're not just going to be looking at the actual representation. You're going to try and make meaning out of it, and you're going to make meaning out of that representation by grouping the elements together. So let's look deeply into what each of these things actually mean in practice. I'm going to give you an example for each of them so that you can incorporate them into your brain. Additionally, where the vocabulary is extremely important for the art composition principles because people utilize them to discuss works of art, these vocabulary terms are more important that you understand the principles, the meaning, the semantics behind it, rather than actually remembering the words. At least in the art world, people aren't typically using words like reification and multi-stability, but these concepts are very important to creating a compelling work of art. Okay, so breaking these things down, we've got reification. And again, you'll remember this is the idea that there's more to human perception than ink on a page. Your brain wants to make meaning out of something. It wants things to be representational. So my question for you is just to take a moment, look at this, and tell me what you see on this page. Technically, these are just shapes. But if I know anything about Gestalt psychology, you will perceive this as an actual serpent that's represented here. So that's the concept of reification. You're not just seeing shapes, you're seeing a representation. Next, we've got multi-stability. This is something that's utilized a lot in any kind of visual optical illusion. And this is a very common one. So hopefully you've seen it before. There's an old woman here. You can see her nose, her mouth, her chin. This is kind of like something that's covering her hair. And then this is her hair. These are her eyes. Or you can see a young woman. So this is her hair. She's looking off to the side. This is her ear. This is her eye, her chin. And then this is her neck. She's wearing some sort of necklace. So in multi-stability, the idea is you cannot see both of these things at the same time. Your brain is going to be flipping back and forth between both of these representations. This is the principle of invariance that we talked about, the idea that you can see something that is rotated or represented in a different way, but your brain will perceive them all as the same object, just being represented differently. So this is what allows us to make a shape and move it around or rotate it inside of P5.JS without confusing people. We don't think, oh, it's over there now, it must be something different. We'll perceive it as the same object. And then last, we've got emergence. This is the concept that we make meaning by seeing things as a group, as parts in a whole, rather than individual components. So when I look at this piece here, I see a neighborhood. I don't just see squares and boxes, nor do I just see houses. I see an entire grouping that means something different than one of those individual pieces alone. So we can take this Gestalt framework and combine all of those ways of looking at human perception to create 8 grouping principles. So these are the actual ways that one might apply this information to creating a meaningful piece of art. Just a quick reminder that these things might feel super obvious to you, but again, very similar to the work that we did in art composition. You need to know the concept of them so that you can start playing with them in your own work and utilizing them to tell stories. I split these things up into 2 parts. You can see part 1 and part 2, similar to what we did with these things, with the framework. We're gonna talk about each of them as an overview, and then we're gonna look at an example so that you can see how those things might actually be applied or utilized. The first 4 we've got here are figure, ground, law of proximity, law of similarity, and law of closure. These definitely apply to things that are typically still, but you could definitely utilize them in motion as well. The idea in figure ground is that your brain separates the foreground and the background of a piece of art, and it will just do it naturally. Your brain really likes to know where the figure is in a piece, and it's going to work really hard to find that figure. I'm going to talk to you in a moment about what actual principles make up a figure versus a background and how you might utilize that inside of your work. The next, we've got the law of proximity. So the idea there is that you perceive things as a group that are close together. So inside of our code, we might put circles really close together and scatter different groups of them around the page to make someone perceive that those things are in the same group. Next, we've got the law of similarity. This is the idea that stuff that looks the same is perceived as a part of the same group. So maybe perhaps instead of putting stuff close together, you have different things of different colors and different shapes. So your brain is going to perceive things that are the same shape and the same color as a part of the group, even if they're separated across long distances on your page. And then last, we've got the law of closure. This is the idea that your brain is going to fill gaps to create a figure. So your brain really likes to see things as a whole. That's what we talked about inside of the principles that make up all of these grouping principles. And we like to make shapes. So even if there's gaps inside of a piece, you'll see it as an actual figure. Next, we've got the law of symmetry, the law of common fate, the law of continuity, and the law of past experience. A couple of these have to do with motion. The idea here is that the law of symmetry is you see things as formed around a center line, and things that are on opposite sides of that center line are going to feel grouped together. So if something is symmetrical, you're going to see those things as a part of a group. The law of common fate is the idea that things that are moving or pointing in the same direction are a part of a group. This is very common in like a flocking behavior. So if you see a school of fish or some kind of birds and there's a group flying east and a group flying west, you'll perceive them as being grouped based on the direction that they're moving. Next, we've got the law of continuity. The idea here is that if a shape goes behind another shape, you'll see that shape as the same. So for example, if you were to create a ball that moves behind a square and that ball kind of like goes inside of there and comes back out, your brain will see that as the same object. Last, we've got the law of past experience. So this one is, I think, in my opinion, the most obvious of these 8 grouping principles. The idea here is that you bring a past experience to the way that you perceive things. And it's super important to remember in your artwork that if you are presenting it to a group of people from a specific culture, you need to be aware that their past experience may vary from a different culture of people. So my favorite example for something like this would be people who read left to right, right to left, top to bottom. You need to be aware that the way that those people see your work of art is going to be different. Someone who reads left to right will also read your artwork from left to right. People who read right to left will do the opposite. Now we're going to break these things down and look at each of them individually really quickly. So the idea here is that you should see a figure and a background. Ask yourself really quickly, what is the figure, what is the background? The idea in Gestalt psychology is that figures are convex, so that means they have like rounded corners, they stick out. They are symmetric, they are small, and they are enclosed. So you never want your figure to overlap on the outsides of your canvas. That may confuse someone as to whether it's the figure or whether it's the background, unless of course that's what you want to do. So if for some reason you're finding that something kind of feels mushy or it doesn't actually feel like a whole piece, try bringing it closer into your canvas, making it a little bit smaller, making sure that it's enclosed, and then giving it a fill also could be great. So a little bit more contrast between foreground and background can make your piece really feel like a figure and a ground. Next, as we talked about, is the law of proximity. Things that are close together look grouped. So the question for you here is, how many groups do you see on this page? In theory, because of the law of proximity and Gestalt psychology, you should see 3 groups. So when you're utilizing things in balance in your artwork and you're trying to create a sense of symmetry, it's really important that you look at how things are grouped inside of your artwork before you start assessing whether something is balanced or not. When you're looking at a piece of art for a really long time, you can lose the fresh eyes, the fresh perception of someone who's looking at your art for the first time, which is why we utilize these principles of Gestalt psychology and art composition so that you can theoretically see this thing with fresh eyes, even if you don't have the fresh eyes. So if you're looking at balance in your piece, you want to make sure your piece is balanced. Something is off or awkward, maybe look at proximity. Do things look grouped inside of your piece? And can you either spread them out a little further or balance the groups rather than balancing the individual elements? We talked about this. So the law of similarity is the idea that things that look similar look grouped. So my question for you would be, how many groups do you see on this page? I see 3. 2. Sorry, I gotta learn how to count. I see an orange group and a blue group, and there is a sense of balance in this piece, but you'll notice that it's a little bit off center because we've got 1 blue on this side and 2 orange, and then we've got 2 blue on this side and 1 orange. So again, how can you combine what we learned last week with what we're learning this week? By seeing things as grouped and then maybe looking at the ways that you can utilize those grouping principles to make a more balanced composition. Oh, one more thing about this slide, things that look the most dissimilar make for the best similarity in your pieces. So squares and circles are very contrasted shapes. So they will be really easy for someone to group squares versus circles. Or you'll want to use color palettes that are complementary, so cool and warm, which is what I'm doing here. That'll increase the contrast between those pieces and it will make the effect more obvious inside of your artwork. Here's another example. We're utilizing squares instead of circles that are different colors. So again, same exact concept here. Things that look different look like they're a part of a different group. Here we have 2 groups, the square group and the circle group. Even though everything is the same color, you should perceive these things as separate groups. Here we have closure. So here you should see a circle, even though these things are broken up, it's a dotted line. So this is great if you want to create a sense of connection or movement in your piece, but you want to do so in a way that's a little bit more visually interesting than just drawing straight lines. This will come back into play later in our coding demo, but essentially dotted lines are a great way to make a sense of movement and a sense of visual interest. It's a type of pattern. And again, back to the line work, elements of composition. You can utilize things that are not connected while still also creating a sense of grouping and a sense of movement. Here we are in our second set of 4. We've got symmetry. Symmetry is the idea that things are symmetrical, look grouped. So I'll ask you here, how many of these groups do you see? This one's kind of fun because I kind of see 2 different sets of groups here. There are obviously 6 individual brackets, and then you should honestly see 2 groups because we've got the law of similarity here. We're working with the different types of brackets, but then you should also see 3 groups. So we've got 1 group here, 1 group here, and 1 group here. So this is a great example of how you can utilize different Gestalt principles in the same piece to create a sense of connection. And that's very similar to the pattern in our art composition principles. How can you create a sense of balance potentially through symmetry? We've got the law of common fate. I've got a moving example for you in a moment, but again, this is the idea that things that are moving together look like they're grouped together. So here I see 4 groups, but I also see 2 groups, and that's because we've got things that are close together, but we also have things that are moving in the same direction. I am also manipulating you a little bit because I have these things scaled differently, so that is going to give a little bit more contrast. And that's the law of similarity, right? So these are a little bit bigger, these are a little bit smaller. Therefore, we're using actually 2 different principles, 3 different principles. So we're using grouping, we're using common fate, and then we're using the law of similarity to create a sense of groups here. And the best example of this is, again, schools of fish. This video is just so lovely to watch. I could watch it all day. We're not going to watch it all day, but you can see these beautiful fish are all moving in the same direction, and so your brain should be perceiving them as a part of the same group. This is a great example. I don't know if you saw them go by. There's a couple fish that are swimming in the opposite direction. They're going to feel like they're a part of a different group. This is so important for the motion graphics work that you do because you want to make sure that everything feels balanced. You want to make sure that your groups are on kind of an even distribution on your page, and utilizing potentially symmetry or common fate can bring a sense of balance into your piece, even if your elements are not exactly balanced on the page. Here we have the sense of continuity. So you should see 2 keys, and those keys should look connected to you in some kind of way, even though you don't see them being connected. So your brain is going to assume that something is continuous if you see both sides, you see those lines connected, even if you don't see the line behind the other piece. So this is great if you're going to use X's, or like I said, you're going to use potentially pieces that are overlapping with each other inside of your work. It's safe to assume that a person is going to see those things as the same when they come out the other side. That also means that the ways that you're balancing a piece and the ways that you're composing a piece need to take into account the missing elements that your brain is still filling in with your work. Last, we have the law of past experience. I have a traffic light here because I think that's a great example. Just about everyone has an association with the colors red, yellow, and green when they are paired together. So if you're bringing that into your piece, be mindful of the ways that someone might be bringing some kind of past experience into the ways that they perceive your work. All right, team, so we did it. This is always a hard topic to teach, no matter how many times I've gone through it. It's just like so much information for me to throw at you all at once. I have these grouping principles just reviewed again inside of this slideshow. So just take a minute to self-check and make sure you understand the concept between each of these. And then if you need to revisit the beginning of the lecture and just double check on any of these, go ahead and go back. So here's the second half of them. It's a lot of information. I'm really grateful that you went through it with me. I wish we could spend more time on it, but I want to make sure that we get the time to also do coding. So I know we went fast. Take a moment to self-check, and then we're going to move on to our code. So math. We're going to look at sine, cosine, and noise. I love sine, cosine, and noise. I think they're like magical concepts. I said this about recursion too. Math and code and the ways that those things can turn into a beautiful piece of compelling art just will never stop being exciting to me. So I hope you're excited to learn sine, cosine, and noise as well. We're going to do a little bit of a trig review, so buckle up. You'll remember from your trig class in high school or middle school or college, whenever you took trig, that sine is a function that represents the opposite side of a right triangle over the hypotenuse. So we've got like a triangle like this, and we've got an angle here, and this would be the opposite side, and this would be the hypotenuse. I have an actual image here. I don't know why I'm holding up my hands for you, but the idea is to utilize the radial coordinate system and some tricks of geometry to be able to figure out the different legs of a triangle. And here's an example. So we've got theta, which is this piece here. We've got the hypotenuse, and then we've got the opposite side. So let's do that math really quickly. Oh, theta, opposite side. I didn't need to point them out for you. I pointed them out inside of my presentation. So we've got the angle, which is 135 degrees. You can use degrees or radians. Here we're using degrees, and you need to make sure that whatever you're using is in agreement with the computational system you have. So your calculator or your P5.JS sketch needs to be in the same radial mode, in the same angle mode, radians or degrees. And then we have the length of our opposite side, which is 1.4. We've got it negative because we're on the negative side of the axis here. And then we have the length of the hypotenuse, which for the sake of ease, the radius of our circle is 2. And either way, if you do this math, you're going to come out with the same number, which is like 0.707. This is one of like the ones that you have to memorize for trigonometry. The answer is the square root of 2 over 2. I'm not asking you to memorize these things. You just need to know the general concept of sine and cosine. So the idea is, of course, boiling everything down. Sine is an oscillatory function that goes between +1 and -1, and it crosses the x-axis at 360 degrees and 180 degrees. It's at +1 at 90 and -1 at 270. So you can see on the right-hand side an animation of what sine actually looks like if you're plotting it like on a moving radian direction. Cosine is exactly the same concept, but opposite. So instead of being the opposite side, it's the adjacent side, which means that where the sine function crosses the x-axis at 180 degrees and 360 degrees, or pi and 2 pi, the cosine function crosses the x-axis at 90 degrees, or half pi, and then 270 degrees, or what is that? So it would be 3 pi over 2. Brain fart. So basically on the right-hand side, you can see here the comparison between the sine function and the cosine function. And we have cosine starting at 1, sine starting at 0. So sine is blue, cosine is green. Same concept. Oscillatory function between 1 and -1. They're just the exact opposite concept. And then this is a review here. So we have a regular pattern that oscillates between 1 and -1. How many times can I say that? And the idea is also that we're moving slow and then fast and then slow. So if you look at the slope of this function here, you see it will get a little bit faster and then it kind of evens out, and then it gets a little bit faster and then it kind of evens out. So the question for you is, what are some types of motion that are oscillatory and move from slow to fast to slow in a regular pattern? A great example would be a flapping wing. So a butterfly wing, a bird wing, something like that. If you wanted to simulate that type of movement, always, always, always go to sine and cosine. Another great example would be a pendulum. I think this is beautiful. You could absolutely, after this course, go and animate this inside of P5.JS. Super simple, and you could set it up where this is 1 and this is -1, and then you're just using parts of the circle to kind of make this beautiful repeating pattern. Gorgeous. Another thing I would point out about this here is that the color is changing in a similar pattern, except for it's not oscillating back and forth. It's going back to the beginning each and every time. So they are actually utilizing some just additive motion here. So I would use some kind of like if statement and say, if we're at the last one, go back to the first one. Great. So what is Perlin noise? If sine and cosine are some sort of oscillation between 1 and 0 that's regular, Perlin noise is an irregular pattern. It also oscillates, but it oscillates between 0 and 1. And the speed change is gradual, but it's irregular. So the idea behind Perlin noise is to take something that's random and make it a little bit more natural. True random should place dots all over the canvas in kind of an even spread. Perlin noise will kind of cluster those dots into certain areas of your canvas. It's much more visually appealing than true random because people like order and groups, as we learned today. And it was invented by this mathematician, Ken Perlin, for the movie Tron. He actually won an Academy Award for his mathematical contribution. And the idea is to make natural looking patterns that are still randomly derived. So a great example of what you could use Perlin noise for is this dog tilting its head. You see it's oscillating, but it's a non-regular movement. It does speed up and slow down, which is something that is definitely doable within the Perlin noise space, but it's not a regular oscillation like sine and cosine, as opposed to that bird flapping its wings, which was very regular. And this is our last example, and it happens to be my favorite. This represents sine and cosine and also Perlin noise. So just self-check what in this is sine and cosine and what in this is Perlin noise. What I see is that the swinging back and forth is sine and cosine. So you can see that's a regular oscillation where things slow down and speed up, and we're not losing any motion here too, just of note. Whereas this like nomming little hamster is moving in an irregular but oscillatory way. So that would be utilizing Perlin noise. All right, so here we are. Let's jump over to our P5.JS editor and go through some quick explorations of all of the ways that you might start utilizing Perlin noise and sine and cosine. So we're gonna go fast. We're bringing a lot of information into this lecture. I'm gonna throw a bunch of stuff at you, so buckle up. But the idea here is just to give you some starting points for utilizing Perlin noise and sine and cosine. inside of that Gestalt Psychology principles to create a piece of art. So we're just going to give you a starting point this week, and then you'll be able to take that as far as you want to go with it. Okay, so we've jumped into our P5.JS editor, and we're going to start by just mapping out what Sine and Perlin noise look like. Just for the sake of things looking nice, I'm going to change our background to be just black, flat black. And then we're going to take our stroke and make it completely white. So we're adding just like a ton of contrast to our piece. And then I'm going to make our stroke weight 3, just so we can have like a really thick stroke, again, high contrast. And then we're going to make it no fill because we're going to use the shape command. I don't know if we've used this yet, but it's a super great command and totally worthwhile to use it. Next, we are going to start utilizing our shape. And we need to make a loop in order to create our sine function. The goal here is we're going to actually graph it out across the x-axis, just exactly the same way as you would see it on any sort of like graph. So we'll create a for loop, same as we always do. Start with I equals 0, I is less than height, and then I'm going to add like 10 just so we make sure that we're going off of the sides of the screen. Oh, I actually want to do width. Here it's trivial because the width and the height are the same thing, but we are moving across the x-axis. So that's why we're going to want to do width instead of height. And then we'll add 1 to I every time we loop. And I'm going to add an end shape outside of our loop. So basically the idea of the shape command is we're going to add a vertex into our piece. So vertex being like the side of a shape. So suppose I wanted to manually create like a triangle, I would actually create like an XY coordinate at each of those places and then do begin shape and end shape. Here though, we're going to use this just to basically draw like a never-ending looping line. And we're going to create a vertex at I, and then I'll just show you how this works by doing I and I. So basically what this should do is create just like, yeah, a diagonal line across our canvas. We could also do I and height divided by 2, and that will just create a horizontal line. So I hope that's making sense. Basically, we're putting 1 point at every single pixel across the screen, utilizing that I loop. So we're doing pixel, 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 and then we're doing it all at a Y position. So this is our X, this is our Y. We're doing it all at a Y position of height divided by 2, so the very center of the canvas. But that's not what we want to do. We want to graph our sine function. So I'm going to create a variable called Y. So var Y. And then our variable Y is going to be mapped utilizing that sine function to the height. So basically what mapping does is it will take the value and then do the math to make it the scale that you want it to be. So basically we're modifying the scale of this function. And the first argument here is the value that's being passed into the map function. The second value is the minimum value of the function that we're passing into the map function. So here sine, the minimum value is 1. The maximum value, or sorry, minimum -1, maximum 1. And then we're going to map the value of -1 to the value of 0. We're going to map the value of +1 to the value of height. So basically what we're saying is everywhere that the sine equals 1, we want it to be the height of the canvas. And anywhere that the sine equals -1, we want it to be at position 0. So now we should get something that kind of moves back and forth between the top and the bottom of the canvas using that sine function. And in order to see that, of course, we need to change our vertex to be Y. Cool. So it's really smushed together, and that's because it's using the 2 pi. So every time we get to the value of about 6.5, we're going to see the function move back and forth. So these are about 6 pixels wide, which is way, 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 way too squished for us to get anything of value out of it. So the best way to change that is just to change the value that's being passed into our sine function and make it smaller as we move across the canvas. So I'm going to divide our looping value of I by 30. The bigger the denominator, the wider your wave is going to be. So now we've got our wave that's going by 60. So each time we go across, we're going I divided by 60, and you see we've got approximately a single phase here, kind of similar to the idea of 6 pixels equals 1 time around the circle. Now we're doing 60, so we're seeing just like you see a little bit more than a single rotation. So this is us graphing sine. If you wanted to graph cosine, of course you can just swap those things out, and now you can see sine and cosine kind of on the actual canvas in your P5.JS sketch. Now let's take this same concept and take it over to Perlin noise. So we'll remember that Perlin noise is mapped from 0 to 1. And we're going to take this function and swap it out with the function for noise. So we'll do noise I, same thing, divided by 30. So now what we see here is kind of this jagged line. We talked about how Perlin noise is something that is also oscillatory, but it's randomly oscillatory, and it's a little bit more jerky. The best way to see the ways that Perlin noise changes, so the randomness concept of Perlin noise, is actually just to refresh your sketch every single time, and then you can see that Perlin noise refreshing along with it. If we wanted to see our Perlin noise actually moving across the screen, we could start to map to something related to the frame count instead of mapping it to I. So I'm going to start making some changes to this sketch so we can actually see our Perlin noise moving across our screen. First things first, we are going to, where should we start? Okay, so we are going to add this variable x offset to our loop. And the idea of x offset is every time we loop through, we're going to add a little bit to our x to change where it is on the screen. Perlin noise, actually before we get into this, I want to actually show you how Perlin noise changes across the canvas. So let's print out our value of noise each time we go through this loop. So let's do print noise I divided by 30, and then you'll actually be able to see as we loop through in your console. Oh, it's not printing. Sometimes there it goes. Sometimes in P5.JS, when you put a print function in a loop function, it just takes a little while to run. So you can see here, as we move across the canvas, so as we're passing in a different value of I or a different x value, because that's the way we've structured our function, we're seeing these values of Perlin noise coming out and changing in a decimal way. So always mapped between 0 and -1. If you wanted to see the actual value that's being graphed, you could always just copy this mapping function and print that out inside of your sketch. So let's give it a minute. And now we can see the function, which is essentially just taking that decimal value and multiplying it times the height. So that's the way you would utilize Perlin noise, and that'll give you like a picture of what the Perlin noise value actually is inside of your sketch. Okay, back to it. Let's actually start creating kind of a scrolling function across our screen so you can see how Perlin noise changes over time. So we have now this function that's creating this random Perlin noise mapping each and every time you run your sketch. But we want to take that and turn it into something that's scrolling across the screen so you can see how Perlin noise kind of changes gradually over time. I also just kind of think this is super visually pleasing, so it's a fun thing to learn how to do. It's quite simple to add. Basically what we're going to do is add something that moves our x value along the side of our screen a little bit at a time, and then we're going to take something that also increments our x value as we move through our loop. So in order to add something that increments our x value as we move through our loop, we're going to add a variable called x offset. And then we're going to make our x offset value equal to 0. And then the next thing we're going to do is add that into our loop. Yeah, my capitalization is all right. And then each and every time we run through our loop, we're going to add 0.005 to our x offset. So basically we're taking the same thing we did with I where we divided it by 30, but we're just standardizing this process. And then we're going to add that in. I'm going to remove this print function because it asks a lot of my computer for some reason. Let's see. Okay, so comment this out. And then we're going to map Y to the X offset. No, we'll map it to I. So every time we go across, we're going to map Y, which is this mapped value utilizing the X offset across the screen. So we should get something very similar to what we got last time. We're just spreading our noise out a little bit farther. So instead of incrementing it by 1 every time we go through the loop, we're actually only incrementing it by 0.005. This is fun because you can see how the noise kind of spreads itself out as you change this value, and how you can have a smooth noise versus like a rougher kind of noise. So now we want to take this and start scrolling it across our screen. And the way we do that would be adding a value that changes each and every time we reload the sketch. So when we're moving through like the frame count per se. So the first thing I'm going to do is make that value equal to 0.01. So we're kind of on the same scale as our X offset value. And then we're going to create a variable called start that we will set our X offset to. We are going to initialize our start variable inside our setup function so that it loads in as 0, but then we are able to change it as we go. So that's going to allow our X to move across the screen as we start moving through our function. And then the last thing we need to do is set our start so that it increases by the same increment every time we move through. So now basically what we're saying is increase our start value each and every time you draw our draw function so that we're moving our X across the screen. So we're moving our X offset inside of this for loop, but we're also moving it outside of our for loop. So we're scrolling it across our screen. And this is really fun because you can start to change, again, the X offset value, so wild. And then you can also start to change the increment value over here. So that allows you to move it faster or slower or what have you. Cool. So this is us mapping our Perlin noise and then seeing it scroll across the screen. I think this in itself is a really beautiful piece of art. Now we're going to take this and utilize it to move some circles around our screen in the Sine function and the Perlin noise function in 1 dimension and 2 dimensions. So let's start a new sketch. Go ahead and save this, make a new one. And then we're going to start drawing some ellipses. So I'll leave my background to 220. I'm going to say no stroke just because I think circles look great without a stroke on them. And then I'm going to create, we'll do 2 ellipses first to compare Perlin noise to sine and cosine. So if you wanted to, you could just double check that you remember how to make an ellipse. You'll remember it's the X value, the Y value, and then the width and the height. So we could do like X value would be width over 2, height over 2, and then we're going to do 30, 30. So now we should get an ellipse in the very center of our canvas, and it's white by default. Now we're going to take this and start doing some noise with it. So we'll do noise is the frame count. Yeah, that's right. And then we should see it kind of moving, but the problem is that we are moving it by just such a small amount that we want to make it multiplied times the width. So we're actually moving back and forth between each side of the canvas. We see this is going super duper fast. So same as always, we're going to divide this by like 30. So you can see it kind of start to slow down a little and you can actually enjoy the concept of noise. And you remember back to what we did on the other screen, this looks so similar. It's almost like it's drawing that line in 2 dimensions for you here. And then we're going to do the same thing with this ellipse, only we're going to utilize the sine function. So we're going to do sine frame count. And then we already know it's going to be super fast. So instead of wasting our time, we'll divide it by 30. We have to map it to the width, but the width, because we're going from -1 to 1, we're going to utilize width divided by 2 rather than multiplying it by the width with noise because noise is a decimal value. And then we're going to do height over 2. So we put this in the center of the canvas again, and then we'll make them both the same size. So 30, 30. Oh, I have 2 semicolons there. Great, so it should be really apparent to you. Oh, so we are going by the width of the canvas, but we need to make sure that we also move it to the center. So let's do width divided by 2 and add that into our sign. Great, so now we have 2 little circles here, and one is oscillating regularly between the left side of the canvas and the right side of the canvas. The other is kind of moving around irregularly. That's obviously our noise function. Just for the ability to tell these apart, because we're going to add 2 more ellipses to this canvas, we're going to add some fill. And this is just kind of like what I think will look good. So we're going to do some analogous colors here. And then we are going to do the same thing. We're going to make 2 more ellipses, and this time we're going to utilize a 2-dimensional noise for our second ellipse, and then we're going to do 2 dimensions of sine and cosine with our second ellipse. So you can see how these things can be translated into not just a linear movement, but actually how are you going to take them into your second dimension on your canvas. So first things first, we'll do noise because we did that first last time. And then same thing, we'll do noise frame count divided by 30 times width. And then instead of just keeping our ellipse at height divided by 2, we're going to utilize noise a second time. So if I do noise frame count divided by 30 times height, what's going to happen is it's basically going to end up moving in a diagonal line because the value of the noise is going to be the same for both the X position and the Y position. So let's just see what that looks like really quickly. Great, so you see here, we're moving at the same X value. So these 2 little dots, let's change our fill so you can see the difference here. We'll do fill 200, 100, 250. So you can see this dark purple dot and this greenish yellow dot are both moving at the same X position. And then this purple dot is doing the same thing in the Y direction. So we're getting just a diagonal line. We don't want a diagonal line, so we're going to actually modify the value that we're passing in to the noise function, and that will make it move around a little bit more randomly. You can do this in 2 ways. You could do this by changing the value you're dividing your frame count by. So you can see now it's kind of moving around randomly in the Y direction and the X direction. Or you could also add a different value to the frame count to give it a little bit of an offset. Oh, the plus sign comes after the 30. So now same thing, moving in the X direction at the same rate as our green dot, but we're moving around in the Y direction a little bit more randomly. Either way works. And then last but not least, we'll change the fill 1 more time so we can make another ellipse. And then we are going to use sine and cosine, and I'll ask you what you think it's going to do, and then we'll see what it actually does. So as we did before, we are going to map this to the width divided by 2, and then we're going to add the width divided by 2 to our function. So we'll add it first, sine frame count divided by 30, and then multiplied by width divided by 2. If you have any hangups on why we're doing this multiplication and addition, feel free to just come to office hours. Basically, the idea is we need to move it to the center of the canvas, which is why we're adding width divided by 2, and then we need to normalize our phase. We need to normalize our height, our movement back and forth to the width of the canvas. So that's why we're multiplying it by 2, because we'll have 1 and -1. So our maximum value will be width, and then our minimum value will be 0. Okay, so next we're going to do the same thing. We're going to do it in the Y direction. So instead of width, we'll do height. And then we're going to use cosine instead of sine, because remember, cosine is the opposite side, or the adjacent side, and sine is the opposite side. So we're going for the X value and the Y value, if you can remember back to the plot that we were looking at. And then we're going to do the same thing. So frame count divided by 30 times height divided by 2. And before I finish out this function, just be asking yourself, what do you think is going to happen when I draw this ellipse. And here we go. So just exactly the same way that you looked at that graph and saw sine and cosine are changing and they're creating a circle map on the graph, we're doing the same thing. So you see this red dot that's moving around, that's how you would create a circle. So if for some reason I wanted my circle to move around faster, I would change this frame count to maybe 30, from 30 to 20. Now you see it moves around faster. And then I don't know if you caught that, but we'll do it one more time. If you start changing the phase, you can do some really interesting movement that's oscillatory. So we're still oscillating the X and Y direction, but we're moving out of phase. So instead of getting a circle, we're getting kind of this like weird, I don't even know what you would call it. It's like a weird pattern around the canvas. And then in addition, you could also make this more of an oval by changing the way that you're mapping the height. So instead of dividing the height by 2, I could divide it by 3. And then you'll see that red dot kind of moves more in an ellipse pattern rather than moving in a circular pattern. And I think the best way to show this is actually to comment out all of this code and then remove our background. Whoa, just the background. We don't need to go that crazy. So now you can see that I'm actually drawing this and it's not refreshing the background, so you can see where it's drawing the shape. So this would be a great opportunity for us to change this to 30, and then I'm going to change this back to height divided by 2, so you can see what that like weird shape looked like, because it'll actually trace it out for us. I love utilizing this tracing function. We haven't gotten into this yet, but utilizing a trace is really fun for drawing like different shapes inside of your canvas, and you could experiment with this. Another great utilization of the background is to use the alpha value. So alpha refers to the transparency of your canvas. So let's change it. And then you can see this sort of slowly fades over time. So you can change that alpha value, and the higher the number, the less transparent your canvas is going to be. So you can think about we're drawing on top of that every single time. So slowly the older path is going to start to fade out, as opposed to when we had no background at all, we just created that red line. So now we've seen how to utilize the noise function in both 1 dimension and 2 dimensions, and also how to utilize sine and cosine to draw circles or kind of weird ellipses, or start to experiment with the face to create some like interesting patterns. And then we also saw how you would actually graph out sine, cosine, and noise on your canvas, moving in the X direction. And of course you could flip that and move it in the Y direction if you wanted to as well. So last but not least, just kind of as a little piece of bonus content, let's look at how you would add some sort of texture to your canvas. So I promised you that we would do this. I'm going to show you where you can find some no attribution canvas or texture, sorry, and then I'm going to show you how you can actually bring that into your canvas. All right, team, so bonus content time. We're going to move kind of quickly. I'm really grateful that you guys have stuck with me through this crazy jam-packed content. I wanted to make sure you could get as much as you possibly could out of this week 3. We had a lot of content to cover, and this texture is just an extra thing to throw in there in case you're interested in how to import textures inside of your P5.JS sketches. Textures are an image file, and I went ahead and grabbed one from this website called freestocktextures.com. You can also utilize a website called Pexels, Pexels.com. Essentially what you're looking for is something that is licensed so that you can utilize it in your art without getting copyright claimed. So we're not going to go into details about how to utilize things that will prevent you from getting copyright claimed, but essentially what you're looking for is free, no attribution images. So if you just go to Google and look up free no attribution texture, you'll be able to find a lot of stock image websites, or you could pay for them, of course. So you could look for no attribution stock textures. Basically, you're just looking for something that you can use without attributing that work to someone else. If for some reason you find something that requires attribution, make sure you go in and put it inside of your comments for your code. It's a really standard place to put your attribution for your images, or you can utilize an image that you've taken yourself. Just make sure you're always giving proper attribution to any images you bring into whatever works that you're working on. So let's talk about how to bring an image inside of your P5.JS sketch. First, you're going to click this little arrow here, And if you click the drop down underneath Sketch Files, you'll be able to click Upload File. This brings up this upload file pop-up, and I'm just going to drag and drop that texture inside of my P5.JS sketch. It'll take it just a second to load in, and you can see it's just an image that's a texture. So you could do this with a regular image as well that has like a subject, but I'm going to utilize this texture. Now, just for simplicity's sake, I'm going to rename this to be texture so that we can reference it inside of our code. And then the next thing that we're going to do is actually import our image inside of our sketch. So in order to do that, we need to utilize this function called preload. Oh, not capitalized, just regular. And then it looks exactly the same as the function setup. We'll add our brackets, and then we need to put load image texture, and then it's a JPEG. So we got to do dots. Before you run the setup function, I want you to load a variable, call it img, and load an image in that's called texture.jpg. So that's referencing our files. If for some reason you had this nested inside of a folder called pictures, so we could say like create folder pictures, and then we could add our texture to it, you would just need to put pictures \texture. But right now our texture is just in our root folder for simplicity's sake. Next, we are going to actually display our image. And the first thing I want to do is load it in as a background. And I want it to be located at 0, 0. I want it to be as wide as the width of the canvas and as tall as the height of the canvas. So now we see we've got a beautiful texture in the background, and we have our circle drawn on top of it. This alone is really cool, and you can take it very far. I think that is enough to add some really cool depth and texture to any sort of image that you're working with. But I also think it's cool to overlay your image on top of anything else that you're using inside of your sketch. So basically the way we're going to do that is take our image and put it at the beginning of our draw function. So now we've got our image drawing each and every time we add something to our sketch. But I don't want it to get lost inside of that dot. So instead of just drawing it every time at full opacity, we're going to mess with the opacity so it'll overlay on top of our circle. And the way that we do that would be utilizing this tint command. And tint only applies to images. Basically what I'm typing in here is I want it to be untinted, so fully white, and then I want the transparency to be 25. So just the same as we did for transparency with our background, the transparency is on a scale of 255, and the lower your number, the more transparent your image is going to be. We're asking for a lot from my computer right now, so I'm going to slow our frame rate down to like 20 instead of 60, the default, and that'll get us a little bit less of a jerky result here. But now you can see that that texture is being drawn on top of our circle, and we're seeing the texture both as a background and as an overlay. So that gives you an idea of how you could maybe potentially work in more than one texture into your piece, or you can just work in a texture as a background. So now you know how to utilize Perlin noise, how to utilize sine and cosine in 1 dimension and in 2 dimensions, and then also how to draw a texture on top of your work. And we've talked a little bit about Gestalt psychology and how things look as they're grouped. I think this is really going to come in handy, both in reference to, like I said, those art composition concepts that we talked about last time, but also in reference to the ways that we do our data visualization next class. So we're going to wrap everything up next class utilizing APIs and JSON files. So that's going to be a very code-heavy class next week. If you're already familiar with JSON files and JavaScript APIs, you're way ahead of the game. Then we're going to take those things and visualize them inside of P5.JS using all the things we've done so far. This one, again, we went super fast, so definitely come by office hours if you have any questions. I really threw a lot of content at you. Also, just go ahead and rewatch whatever I put up here. I tried to be super thorough, but I know that it went by super quickly. So take your time with this, really make sure you understand what we visited today, and then we'll be able to stack that all on top of each other for next class. So I look forward to seeing you to learn some data visualization.